a little bit longer than infrared, if we go a little bit farther over, longer than infrared, we're going to have microwaves. And there's one more category that's longer than that, but we'll talk about that one next time. Let's just finish up with microwaves here. Have you ever heard of microwaves before? Have you heard of microwaves before? Give me a yes or a no, and while you're doing that, I'll write out the range. Microwave is any light between 1 millimeter and about 10 centimeters. So microwave is any light with, like about that to about that on your own body, right? Yeah, you've heard about it in a microwave oven, right? So microwave, the type of light that microwave ovens use to cook food is microwave light, right? Now, that said, okay, what is more dangerous? If you have an equal amount of two beams of light, and one of them was infrared, and one of them was microwave, which one would be the most dangerous to you? Is infrared light or microwave light, in general, more dangerous? So that's exactly what I was expecting to hear, because the whole reason I asked this question is there's a big misconception that pretty much everybody has. Infrared light, in general, with an equal amount, is more dangerous than microwaves. And visible light is even more dangerous than either of those guys. Why would visible light be the most dangerous of these three types of light? It's because of one of the properties, one of the three properties. Yes, actually, somebody said it kind of in another thing. It's the energy level. So in general, the higher the energy of light, the more dangerous it is. It can have a bigger impact on you, essentially. So visible light is the most dangerous of these three. We're going to see more that are even higher energy next time that are even more dangerous than visible. But you probably think of microwaves being the most dangerous because everybody's real scared of the microwave oven. And they should be, because just being less dangerous doesn't mean not dangerous, okay? But we'll get to that in a second. With that in mind, let me point out one other thing. Can you tell which color of light is the most dangerous color of light for your eyes? Which color of visible light is the most dangerous? Violet light. Violet light is the most dangerous. That's why if you look at, you probably have heard of black lights before. Black lights aren't really black. They're that bright violet purple color, right? And they kind of hurt. Like if you've ever stared at one, don't stare at them. But if you did, it kind of hurts to look at them. That's because that light that's coming out is very high energy and your eyes are reacting to that. Whereas red is the least dangerous kind of light. That's why red light is used in a lot of situations where we don't want to have the light affect things as much, like in a dark room for like developing photography. It's frequently in red light there so that you can see, but because red light is the lowest energy, it won't damage the film as much as the other kinds of light. But yeah, so microwaves, if they're less dangerous than these other types of light, then what causes them to cook food? It's going to be tied into something we're talking about next time. But for now, I'm going to go ahead and tell you this. Every substance, like water or oxygen or arsenic or anything. Every substance has certain wavelengths it really, 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 really likes to absorb. And it turns out that water, very common substance, you probably have heard of water before, right? Water has one wavelength of microwaves that it really, 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 really likes. So that if you're water and that wavelength comes along, it will grab that light and absorb it. And here's the thing. Because water likes that wavelength so much, it doesn't matter that it's a very low energy. It's going to take in a lot of that wavelength. And anytime it absorbs that wavelength, what will happen to its temperature? If you've got a particle of water right here and it absorbs light, it will get hotter, right? It will get hotter. So, if you design a box to shine that one wavelength, then any water you put in that box will absorb that one wavelength. And even though that wavelength is not very high energy, it'll absorb so much of it that it'll still get hot. Now, that's your microwave oven. So here's the thing. Why does a microwave oven work? Well, what does all food have in it? What does all food have in it that would help a microwave oven to cook it? What substance is in basically all the food? Water, right? So basically what happens in a microwave oven is that the light in there is not dangerous for stuff that isn't water, okay? But because food has water in it, those microwaves will go through the food harmlessly until it hits water. And then it gets absorbed, and it will cause the water inside the food to heat up. And that water doesn't want to stay hot, so it will try to give off that heat to the rest of the food. So the food gets cooked from the inside out by its own water. And that's also why it's dangerous for a human being, okay? That one wavelength of microwave light is dangerous to a human being because what's inside of a human being? What's inside of every one of us? What is our body mostly made out of? Yeah, we're water. We're water, right? We're made of lots of water. So it turns out that because our body has so much water in it, we would also cook if you shine that one wavelength of microwave. All the other wavelengths are basically harmless. In general, microwave is harmless, but there's one single wavelength that because we have water in us, our body would like to absorb in high amounts, which will cook us from the inside. Okay, so don't get into your microwave. It's a bad idea. Final point I want to make for today. A regular oven uses infrared to cook food. You can tell that because a regular oven feels hot inside. A microwave oven uses microwaves. A regular oven uses infrared. Which type of oven, a regular oven using infrared or a microwave oven using microwaves, which one takes more electricity to run? Which one takes more electricity to run? A regular oven with infrared or a microwave oven with microwaves? So it turns out it's the normal oven. It's the regular normal oven. Here's my last question of the day. Why? Why? Why is it that a regular oven using infrared would take more? Well, it doesn't. Oh, so yeah, okay. Some ovens are gas powered, but but I'm still talking about energy. So maybe not more electricity, but it would take more energy no matter what you're making to run. And the answer is, it's because, yeah, infrared is a higher energy light, so it takes more energy to run it. Whether that's in the form of electricity or gas, it would take more to run the infrared because it's a higher energy. That's why one of the reasons that microwaves were invented, because they run on less electricity over the same period of time than a regular oven.